Welcome back to the channel. Today let's solve LeetCode problem 392 is subsequence. So given two strings, s and t, determine if s is a subsequence of t. That is, all characters in s must appear in t in the same order, but not necessarily contiguously. We can delete some characters from t to get s. In this example, we see s is going to be ABC, t is going to be AX, BX, C. The output is going to be true because we can remove x and x here, and then ABC is going to be ABC in the same order. And here we see s is equals ABC, t is AXB, false because this entire subsequence of ABC is not containing in this t string. So the approach we're going to take is we're going to initialize a pointer res to track the current index in S. We're going to iterate through each character in T. If the current character in T matches the S res character, we're going to increment res. And if res is equal to the length of S, we can return true because we found all characters in S in a correct order. And if the loop reaches the end and res is not equal to the length of s, we're going to return false. So let's look at an example here in real time. So we basically have a condition that says if res is equal to 3, we're going to return true. And 3 is going to be the length of this subsequence s. So we're going to have a pointer here that's going to be the iteration pointer, and we're going to have this res value. For each iteration, we're going to say, okay, is the character at t equal to the character at s? In this case, yes. So we're going to increment. And remember, in this example, every time we increment, we're going to check, is res equal to 3? In this case, no. So we're going to keep going. Is x equal to b? No. Keep going. Is b equal to b? Yes. We increment. And remember, each time, is res equal to 3? No. And then we're going to keep going here. Is x equal to c? No. Is c equal to c? Yes. 3. 3 is equal to 3, so we're going to return true. Now let's get into the actual writing here. So we're going to create that initial res variable. We're going to do for character in t if c is equivalent to the s value that we're on. So we're going to take this number as the index in the string here. We're going to say if this character in t is equal to the character we're on, we're going to increment res. And we're going to say if res is equal to the length of s, we're going to return true. And then if we reach the end of the t iterator, we're going to return false, as there is no subsequence that we determined found in t. So now let's do a little test here. And we're going to use this example. So we are going to use t as ax, bx, c. Okay. So we're going to do if res, or if whatever the number is equal to 3, because 3 is the length. So okay, so in this first example, is c equal to res of 0 with s. Let me is C, so C is going to be A. Is A equal to A? Yes, it is. So we're going to increment res. So res is going to be 1. And we're going to say, is 1 equal to 3? No. So let's continue on in the iteration, x. So is x equal to b? Because res is 1 now, and we're on the second character. Let's do this res variable. So is x equal to b? No. So we're going to continue on the iteration. B. Is b equal to b? Yes. Then we're going to increment res. Res is going to be 2. And we're going to say, is 2 equal to 3? No. So let's continue on the iteration. Now we're at this x here. We're going to say, is x equal to c? No. Continue on. And then now we're in this last iteration here. We're saying, is c equal to c? Yes. We're incrementing res. So res is going to be 3. Update 3 here. Is 3 equal to 3? Yes. And we're going to return true. So thinking of the time and space complexity, when looking at time, this is going to be a linear solution where n is the length of t. So in the worst case scenario, if no sequence is found, we need to iterate through the entire string t. So in this example, right, if s is abc, we need to find this substring. A, B, and C is not in this string. Specifically, C is not here. So we just need to iterate through all of t, and that's that worst case linear time solution. Space, so no additional data structure was needed, right? If you can see the code above, we just used variables and really like a two-pointer approach. So it's a constant solution, meaning we didn't need that extra data structure. So when looking at optimization, this solution is highly efficient due to its constant space and linear time complexity. And even in the best case scenario, when a subsequence is found early, the algorithm is going to exit immediately, improving performance. So for example, let's say we have this long string here. We're going to exit right here because we found that subsequence right away. So let's test this code to make sure it works. Green there. Ooh, what is this bug here? String index is out of range. Okay, so here, okay. So because there's no, because this S string is empty, we can't index in here. So to fix that, let me get rid of some of this stuff. We're going to say, if not S, return true, because that automatically makes it a subsequence. And let's use this as a test case to make sure it works. We're going to submit. And it's all green there. So let's look at the final code. So there was an edge case where this was empty and we were indexing in. We were indexing in here, and that threw an index error because there's no string to index in. So, but this really cleaned that up. So thank you for watching and hope to see you next time.